Week 1 question, 4 expert witnesses, and an answer. Cast your mind back to science lessons at school. You may remember an experiment in which you took a beaker of water and put 2 metal electrodes in it, perhaps a couple of nails, and connected them to a battery. As the electricity started to flow, little bubbles appeared on the metal surface. On one side hydrogen, on the other oxygen. H's and O's, as the electricity broke down the H2O of water into its component parts. Oxygen we know about, we could use it in hospitals. But hydrogen is incredibly useful too, because it burns. And we could use it to heat our homes, cook our food, and power our vehicles. And crucially, when it burns, unlike the gas we get from the ground, all it produces is water vapour, those H's and O's combining again and disappearing into the air. Now, imagine that school experiment scaled up to an enormous size, perhaps generating renewable energy with solar panels, maybe in the Sahara Desert or somewhere like that, and using that to produce totally green hydrogen to power our lives. Wouldn't that be an amazing way to reduce our carbon emissions and tackle climate change? So for this episode of The Inquiry, we're asking, will hydrogen solve our energy needs?
Part 1. What is hydrogen?
Hydrogen is a small molecule. It's only got H's in it, hydrogen atoms, and can be used as an energy source. I'm Rachel Rothman. I'm a Professor of Sustainable Chemical Engineering at the University of Sheffield, and I'm involved in the UK HiRes project, which is a hydrogen hub looking at how we solve research challenges around hydrogen. And when you burn hydrogen in air, you produce just water vapour. We can burn it directly in a small boiler like you have in your home, or it could be in a large industry. In a heavy goods vehicle, for example, you could either use the hydrogen directly in an internal combustion engine, or you could have it powered by a fuel cell where the hydrogen generates electricity.
The challenge, though, is that however we use hydrogen, we need to make sure it's produced in a clean way to begin with.
Hydrogen doesn't exist naturally on Earth, but you can find hydrogen in water, you can find hydrogen in hydrocarbons. Oil and coal and gas all also contain hydrogen. To get hydrogen from a hydrocarbon source, often we use something called steam methane reforming. So that's where we take the hydrogen from natural gas, and that's a process that's done all over the world. And right now we produce approximately 120 million tonnes of hydrogen around the world every year. The problem with that is that carbon dioxide is produced in the process.
And that's where electrolysis, that school science experiment, comes in.
So a better way to get hydrogen will be to take it out of water, because if you take hydrogen from water, all that you leave behind is oxygen. The most common way of doing it is using a process called electrolysis.
These different ways of making hydrogen have led to it being described using a series of colours, grey, blue and green, which indicate how much carbon goes into the atmosphere when it's produced.
Grey hydrogen is the type of hydrogen that we have right now through steam methane reforming. Blue hydrogen is the same as grey, except instead of releasing that carbon dioxide, we're going to capture it and do something with it. Green hydrogen is hydrogen that comes from water through electrolysis, powered by renewable electricity.
Obviously, it would be amazing if we could make all our hydrogen either blue or green. That would cut the amount of carbon dioxide we put into the air enormously. And we'll hear more about blue hydrogen and the challenges of carbon capture in part 4 of this programme. But that goal, says Rachel, is some way off.
We certainly can't make as much green hydrogen as we're predicted to need if we're to meet our net zero targets. In the shorter term, we're absolutely going to keep needing some grey and also the blue hydrogen, because you wouldn't want to wait until the day where you have enough green hydrogen to suddenly say, right, now let's start using hydrogen, because you wouldn't have the technology developed and ready.
So what about the idea of carpeting the Sahara Desert with solar panels and making all our hydrogen there?
One of the challenges is, if you made lots of electricity in the Sahara Desert, you would have to then get it to somewhere where you wanted to use it. Because quite often the cases where you have intense energy, like in the desert, that's not actually where you want to use it. Hydrogen is a very small molecule, which makes it very easy for it to leak small amounts. Now, small amounts of leakage are okay, they're not a problem, but if you transport over a long distance, you find that you don't have as much left at the end of your pipe as you had at the start of it.
And she says, if we put it onto ships and transport it to where we need it, we're going to have to start thinking about the carbon impact of that too.
If you're going to move all your hydrogen around but use a ship that's powered on fossil fuels, have you just completely defeated the purpose of moving that hydrogen around?
So it looks like the best way for us to use hydrogen will be for us to make it near where we want to use it.
The most efficient way to do that will be for them to electrolyse their hydrogen on or near site, because then they can use it without losing any along the way.
Does that go down to street and house level? I mean, could a bunch of us have in the back garden a hydrogen electrolyser?
If you needed to have hydrogen, there's no reason you couldn't do that.
There's also the issue of how much all of this will cost.
The challenge is not can we do it, it's can we do it cheaply enough for it to make sense. And one of the challenges with electrolysis, you have to have electrolyzers that will work on a large scale and that will last for a long enough time. And if they're not either durable enough, or if you can't build them at a big enough scale, then you can't make the amount of hydrogen that's needed. So the challenge is being able to do it cheaply and efficiently enough to make it economically viable.
The Explanation is the podcast from the BBC World Service that goes beyond the spin, exploring the important questions about long-running stories and the latest global news. An honest explanation of the events shaping our lives. Search for The Explanation wherever you get your BBC podcasts.
Part 2. Planes, Trains and Automobiles.
A huge amount of the energy we use and the carbon we produce comes from moving people and things around the planet. We're getting used to seeing electric cars on our roads, powered by lithium batteries. But bigger vehicles like lorries, ships and aeroplanes need more power than those batteries can produce. And that's where hydrogen could be the answer.
We see it playing a particularly important role in marine and in heavy-duty trucking.
Our second witness is Thomas Walker, Transportation Technology Manager at the Clean Air Task Force, a global organisation that promotes scientific solutions to the challenge of reaching net zero. He says we could use hydrogen to power those ships that carry goods and people around the planet.
Large container ships that are bringing goods from across the country or from internationally, for example, China to LA is a very popular route. We see those ships, which is around 2 or 3% of global transport emissions, so not the biggest category, but we see that as being decarbonized by mostly either ammonia, which is nitrogen and hydrogen together, and potentially, to a certain extent, hydrogen as well.
And in lorries, we could use hydrogen instead of diesel to power internal combustion engines, which may be a better option than using batteries and electric motors.
The biggest issue you have with batteries is not very much energy on board. And when you have a large truck and you need to drive, let's say you're hauling goods across country for deliveries, or you're moving things between warehouses and you're driving 500 miles, 1,000 miles, even 2,000 miles is not uncommon in the US, you would have to stop and recharge the truck. And the battery is so large, maybe 1,000 kilowatt hour battery you have on this compared to like a 75 kilowatt hour battery you have in your passenger vehicle. It takes over 5 hours to charge this battery. In a comparison, if I'm just pumping hydrogen into the truck, it only takes about 20 minutes.
To do that, though, we're going to need to have hydrogen stations that we could drive into and refuel at. And those present their own set of challenges.
The big difference between hydrogen pumping stations and what we currently have with diesel or gasoline is that the diesel, that's a liquid, and so that's very easy to pump, but hydrogen is stored as a compressed gas. Usually stations will store it at 100 or 200 bar or 100, 200 times atmospheric pressure, and then when you compress it and put it into the vehicle, that's actually stored at around 700 bar. And the increase in pressure is owing to the fact that you have much less room, and that process leads to a very, very complicated hydrogen dispenser. And also, without getting too far into the weeds of thermodynamics, when you compress a gas like that, it will heat up a lot. And so you have to be careful to make sure that the state of the gas is correct when it gets into the truck.
And if that hurdle can be overcome, people will need to be sure that we have enough hydrogen stations on the road. You may remember that in the early days of electric cars, people were reluctant to buy one as there didn't seem to be many places where you could recharge them.
There needs to be infrastructure that's developed. And I think to get us started, we'll need some government incentives.
And what about planes? Will hydrogen be the answer to the guilt many of us feel when we fly off to a week in the sun?
We think that hydrogen will play a role in aviation. It's an important sector of transportation to decarbonize. It's around 10% of global transport emissions.
And when it comes to aviation, we're making progress. Over the past few years, a number of companies in Europe and the US have carried out trials of hydrogen-fueled planes, usually smaller planes on short test runs, and the results have been good.
What we've seen recently is that certain smaller planes, that test seemed to be fairly successful in terms of actually having the engines, converting them to run on hydrogen.
From ships to lorries to planes, hydrogen looks like playing a significant part in the decarbonisation of transportation. So when will we see fleets of hydrogen-powered vehicles delivering goods, crossing the sea and flying us through the air?
There's been a few demonstrations of large heavy-duty trucks that are powered by hydrogen. So we think hydrogen especially will play a big role in this hard-to-abate sector. Large container ships that are going to be debuting maybe around the end of this decade. Aviation will likely take the longest. We see mid-2030s or maybe even 2040 before you really truly see a cross-country flight or international flight with decarbonized fuels.
Part 3. Heating homes and powering production.
As well as fueling our lorries, ships and planes, hydrogen could also be used to heat our homes and to cook with. Just like in many countries, natural gas is used now. Our third witness is Sarah Walker, Professor of Energy at Newcastle University in the northeast of England.
Natural gas provides us in the UK with about 83% of our heating needs in buildings. So in order to meet some net zero commitments that the government has put in place, it's looking at alternatives, of which hydrogen is one of those.
To find out more, the UK government is proposing to begin trials in 2025, which will look into how feasible it is to switch over the country's gas supply from natural gas to hydrogen. It plans to move about 2,000 houses in Whitby, just outside Liverpool in the northwest of England, and in Redcar across the country on the northeast coast, over to a 100% hydrogen supply for their heating and cooking. And that's going to mean some changes, not so much in the gas network, but more inside those homes themselves.
We will need to change the gas boilers in those homes, and potentially if gas is the form of cooking, then we'll need to change cooking appliances. And if those homes have natural gas fires, then the feature fireplace as well potentially would need replaced. What we're hoping to discover is how this works for the homeowner. So what difference, if any, do they see, and how can we ensure that that difference is still acceptable? We're also wanting to see how the overall system performs as well. So how are the pipelines operating? How are we making sure that there's enough hydrogen going into the system to supply the end user?
In fact, the UK has already run a smaller trial like this, using hydrogen to heat buildings on a university campus in the West Midlands. And the results were promising.
We've done some blending up to 100% hydrogen at Keele University because they have a private gas network on there. That was done in November 2019 through till March 2021. The overall feeling from the end user was that they saw actually very little difference in terms of the temperatures that they were able to achieve in their buildings.
And if the trials in Whitby and Redcar deliver similar results, One option will be for the UK to move its entire gas network over to hydrogen.
The UK wants to make a decision on hydrogen heating by 2026 so that it can then start identifying what that means by way of investment in gas infrastructure for conversion to hydrogen, or potentially investing that money instead in the electricity network.
The big question, of course, as all of us around the world are wrestling with sky-high natural gas prices, is how much hydrogen will cost.
So at the moment, hydrogen is more expensive, and the way that hydrogen is made at the moment, about 97% of the hydrogen that's made in the UK is made from natural gas.
That's the grey hydrogen our first witness told us about.
And so, as a process, it does mean that the price currently of hydrogen is higher than the price of natural gas. And we're looking at ways in which that can be cleaner so that we're not relying on a fossil fuel, but also cheaper in the long run.
Even if we manage to get the cost down, heating our homes may not be the best use of hydrogen, especially while we're in the early stages of moving away from natural gas. Industry, says Sarah, could be a better early adopter.
It makes sense for us to think about industry as the very first end use of hydrogen rather than the home. Those industry sectors like the metals, the chemicals, the food and drink sector, ceramics and glass, those sectors that require high temperature, it makes sense for us to think about whether hydrogen would be a good fuel use to provide that heat for them.
And as for how we heat our homes, Sarah stresses that hydrogen isn't the only answer.
The trials are a good idea because the decarbonisation problem is very complex and we need further evidence in order to make these really quite big decisions around what the heating of our 26 million or so homes will look like.
Part 4. Is this all just hot air?
It's an expensive approach to go. It's potentially dangerous. And if we use the hydrogen that's generated from renewable electricity, that's an extremely inefficient way to use the renewable electricity. You'd get a lot more heat in a home simply by taking electricity directly to the home and using high-efficiency heat pumps.
Our fourth witness is Robert Howarth, a climate scientist at Cornell University in the United States. As I'm sure you can already tell, he's sceptical about all the excitement surrounding hydrogen as a green fuel.
Hydrogen in the past has not really been used as an energy carrier very much. It's been used mostly as an industrial feedstock. We use it to make synthetic fertilizer, we use it to make plastics, and we use it to refine petroleum. Those are the major uses. And some energy experts have been talking about using more hydrogen in our decarbonized energy future, and I think it does have a role to play there, but it's going to be a small role, and I think it's been wildly overhyped, particularly in the last few years.
Robert argues that electrolyzing hydrogen from water is simply not a good use of electricity.
When we use electricity and we convert it to hydrogen, there's an inefficiency right off the bat. We lose some of that useful energy. And then we transport the hydrogen to the home, which is a difficult process as well. And then you burn the hydrogen in the home, and that too is inefficient. So at best, you're going to get about 45% of the initial energy of that electricity as heat in the home. So basically, for the same amount of electricity, if you're using the heat pump, you're getting 6 to 10 times more heat energy in the home than you are by burning the hydrogen.
And he is scathing about the concept of blue hydrogen that we heard about in part 1, the hydrogen that's produced from fossil fuels, with the resulting carbon dioxide captured before it can enter the atmosphere.
Blue hydrogen is really the invention of the oil and gas industry, and the term's been around for well under a decade. Unfortunately, it's not that easy to capture carbon dioxide. It's a little bit better than gray hydrogen, but not by much. It still has a really, really big greenhouse gas footprint, larger, in fact, than if one were to simply burn natural gas.
And he says it's not true that hydrogen itself has no effect on the atmosphere.
Hydrogen, when it leaks to the atmosphere, does contribute to global warming. And that's because it changes some of the atmospheric chemistry. It makes methane last longer in the atmosphere than it otherwise would, so it amplifies the warming from methane. Some of the hydrogen reaches high into the atmosphere, into the stratosphere, where it's oxidized to water vapor. So it contributes water vapor to the stratosphere, and that contributes to global warming. We want to use as little as possible and use it as effectively and as efficiently as we possibly can.
So why does he think hydrogen is the subject of so much excitement at the moment?
It's being incredibly hyped by governments and by industry. If you look at where that's coming from, it's coming from big oil and gas. This idea that we'd use hydrogen for heating has only been around since about 2018 or so the last 4 or 5 years. And the messaging started with a group called the Hydrogen Council, which was established in 2017 by big oil companies. And they've promoted it very, very heavily to politicians, to the press, and to the public.
Why are they promoting hydrogen? It seems an odd thing for big oil to do.
Well, I think there are two reasons for them to do it. What they're actually promoting at the moment is that we continue to use natural gas, and we continue to use the natural gas pipeline distribution system, but we start to blend hydrogen into that. And then they suggest that perhaps eventually, without ever specifying what they mean by eventually, it'll be all hydrogen. The current pipeline systems aren't meant to handle hydrogen. They might take 5, 10, maybe up to 20% hydrogen mixing in with natural gas. Beyond that, it's clearly not safe. I think the real interest of the oil and gas industry is to justify the continued use of their pipeline systems. I think they must know, because the science is so clear, that we're never going to go to high levels of hydrogen for home heating. But it sounds good in the meanwhile, and perhaps it buys them another, decade or two of continuing to market natural gas and continuing to earn profit off of their pipeline system.
Robert does see a use for hydrogen in our future energy mix, but he says it'll be much smaller than many people are advocating.
I think its role will be limited to things like making steel, and using hydrogen to make steel instead of using coal is a wonderful way to reduce greenhouse gas emissions, and using hydrogen to power planes may well have a bright future. But when we look back, I don't think there'll be a single home in the world that's heating with hydrogen, and I think people will laugh at the idea.
So now we return to our question. Will hydrogen solve our energy needs? Well, the answer is probably not. It certainly looks as if it will have a big role to play in industry and in powering the big ships and lorries that carry goods around the planet. And I like the idea of zero-emissions planes. But as all of our witnesses have said, we're going to have to see it as just one part of a much bigger set of solutions we develop to solve our climate crisis. A final word from our second witness, Thomas Walker of the Clean Air Task Force.
We can't just pigeonhole ourselves into one technology. No one knows the future. Any number of things could occur, and so we need to give ourselves decarbonization options. And if we have hydrogen as one of those options, we think that we can actually achieve decarbonization by mid-century.
This edition of The Inquiry was presented by me, David Baker, and produced by Christopher Blake. The editor was Tara McDermott, and it was mixed by Nikki Edwards.
Hi, I'm Claire Graham.
And I'm the BBC World Affairs editor, John Simpson.
And we'd like to tell you about a new podcast from the BBC World Service, The Explanation.
The Explanation looks beyond the headlines, bringing you in-depth analysis of the stories affecting our lives.
Whether it's important, long-running issues,
or the latest global events.
We're making sense of the big stories.
And giving you an honest, unvarnished explanation of the world.
Search for The Explanation wherever you get your BBC podcasts.